Okay, hope everyone's doing well here. This is exactly like the paper version you got before break, the day before, except for this column for power. And what is power? That's just I times V, current times voltage. Whenever you're solving for these circuits here, the other important thing to remember is that I, current, is V divided by R, which means that if I know two out of these three variables right here, I can solve for the missing third. So let's start with this circuit right here. This one right here is a series circuit. There's just one path for the electrons to follow. Let's think about formulas. Like if I thought about an equation for current, well, the current that I start with, sometimes called IT or I0, how does that equal I1? This current is going to flow through that 5 ohm resistor. The same 3 amps will flow through that 3 ohm and then through that 2 ohm. All these currents through all these branches will equal each other. So as an equation, you could say this for a series circuit. So that means I know that all these will be 3 amps apiece. Now for voltages. How do voltages work? Voltage is energy. So I have this total energy that the battery gives me, is 30. And I have that energy to lose through these resistors. So each resistor gets to take up part of that voltage. So if I added up the voltages through these three resistors, they're all going to add up to be that total voltage that I started with. Also resistance. So how does resistance work in a series? Well, it just adds together. However many you have, add those up and you will get the total resistance. So right here I started with 30 volts. And here I have, let's call this resistor 1, 5, 3, and 2. How can I find these missing V's? I can rearrange this equation right here. V, if you rearrange that correctly, would be I times R. So 3 times 5, that gives me 15, or 3 times 3 is 9, or 3 times 2 is 6. A way to check your answer right here is that you can add these three voltages up, just like this equation tells us, and they should equal that voltage you had at the beginning. So that works out right there. Now what's the total resistance? I could do it two ways. I could just add these up because that's how resistors work in series. 5 plus 3 plus 2, that will give me 10. Or I could have rearranged this equation right here, Ohm's law, for resistance. And resistance would be V divided by I. So if I took 30 divided by 3, I would get 10. For the power column, just multiply I times V. So 30 times 3 is 90, 15 times 3, 60, 3 times 9, or 3 times 6. The way to check that is all the power equals the beginning. All right, so this circuit right here is a parallel circuit. And for parallel, it means it has more than one way to go. And how does that work for current? Again, current is the electrons moving through the wire. If I have 6 amps leave, some of the current might go down this way, but some of it continues on and then goes down the other branch. So what ends up happening is that these two branches here, I1 and I2, add up to be the overall current. And voltage is energy again, energy per charge. So if I start out with 30 volts of energy here with this battery, what does each individual electron get to do? Well, it gets to go through this wire and maybe through this first resistor to get around to that other side of the battery, or some of it goes down this way through the second resistor and back to the battery. So each individual electron actually only gets to go through one of these resistors. So both of those voltages will equal the total voltage you started with. And then how does resistance add in parallel? That's that equation, 1 over the total, or let's say 1 over Rp is 1 over the first one plus 1 over the second plus however many you have. Let's fill in what we know here. We know that the original voltage was 30. I have current of 6 at the beginning, and I have these two resistors of 10. What can I find next? I could actually find this resistance right here, this total, two ways. I could do it with this equation for parallel circuits for resistance and say 1 over the total would have to be 1 over 10 plus 1 over 10. Add those together and I get 2 over 10. But that's 1 over the total. So what you want to do at the end is flip it over. That means the total resistance would be 10 divided by 2, or 5. But there's another way to find that. We could do it with that equation, that R would be V divided by I. So if I know this V right here, 30, and this I right here is 6, I would just take 30 divided by 6, and I can still get this 5. Let's see what else we know in voltages. Well, in parallel, we have this equation. They're all equal. So these are going to have to each be 30. And the current. Well, now I can find it because I have a V and an R. So 30 divided by 10, because I is V divided by R. So that would give me 3 and 3. Sometimes these aren't going to be the same value here. They're only the same value because the resistance was the same. But if one had a larger resistor than the other, that would actually have less current going down that branch. And power again is I times V, so 30 times 6, 180, 30 times 3, 30 times 3. So hopefully those two went pretty well for you. Let's look at some others. Okay, I'm going to fly through these a little quickly because I went through how those equations work. But this gives me 15 minutes of recording time, so I'm going to try to hurry and get this in 15 minutes. The total voltage was 9. It started with 1 amp current. I don't know the total resistance yet, but I know the first one is 4, 3, and then a 2. Now to find this total resistance, these would just get added together. 4 plus 3 plus 2. That would give me 9. Now what do we know about voltages or currents in a series circuit? If you're thinking voltages, no. I would be thinking currents. If it's a series circuit, all the currents will equal each other. So how do I get these V's? Well, V would be I times R. So 1 times 4, 1 times 3, 1 times 2. A way to check my answer is that all these voltages right here have to add up to be the initial voltage. Whatever the resistors lose, the battery gets. And then power again is I times V. So 9 times 1, 9 times, or 4 times 1, 3 times 1, 2 times 1. This circuit right here is actually a parallel circuit. Might look a little odd, but the current can either go through this 3 to get back to the battery, or it can go down this branch, go through this 3 and get back to the battery, or it can go down this branch and through this resistor and still get back to the other end of the battery. So there's 3 ways to go with 3 resistors. So the total voltage here was 9. The current total was 9. And I know these are 3 ohm resistors. The total resistance, again, I could do that 2 ways. R would be V divided by I, so 9 divided by 9. Or I could have used that equation for parallel circuits. 1 over the total would equal 1 over 3 plus 1 over 3 plus 1 over 3. That will give you 3 over 3. Flip over 3 over 3, and that's still 3 over 3, which is 1. So you still get the same resistance either way. It's a way to check your work if you want. Now, what do we know about either currents or voltages in a parallel circuit? Well, the voltages are all going to equal. If it gains 9 volts through this battery, this resistor would be able to lose that 9 volts to get back. The wires lose maybe a little bit of voltage if you did those FET labs, but technically it's about 0, and most of the energy is changed into heat through those resistors. What do we know about current? It's going to split up. And because these are equal resistors, they're going to split up equally. I had 9 amps to begin with, so it's going to split it up into 3 groups of 3. But a way to calculate it is just V divided by R. I could have said 9 divided by 3 and get 3. Same thing here and here. And then the power is I times V. So 9 times 9, or 9 times 3, 9 times 3. Holy crap, 3 there. And the last one, 9 times 3. Okay, we have 5 more minutes, and the last one is a combination circuit. Why is it a combination circuit? It's part series, part parallel. The series part is the part that current has to go through. All of it has to go through there. So if current leaves here, it all has to get through that 6 ohm resistor there. So that's the series part. And then it splits up right here into 2 branches. So the current gets to split up. Another way to, I am so sorry, what did I just do here? It is. Another way to tell it's just parallel, or I'm sorry, no, I don't know what's going on. That it's not either series or parallel is because if it was just series, there would only be one way to travel. If it was all parallel with 3 resistors, there would be 3 different ways to travel. But there's only 2 ways to go for this current with 3 resistors. So it's kind of following the rules of both series and parallel. It can go through this branch here, or go down here and go through this branch to get back to the battery. So let's put down what we know. We know the total voltage starts with 10, started with 1 amp of current. We know resistor 1 was 6, and the other 2 resistors are 8 ohms apiece. Now, if I wanted to find this total resistance, because I know the V and the I could do it that way, but you should understand how that would work with just adding resistors. So I have that 6 ohm resistor, which is in series with these 2 8s that are in parallel. So what I'm going to do is add these up first in parallel. And how to do that is to say 1 over 8 plus 1 over 8, and it would give you 2 over 8, which you could reduce to 1 over 4. But you have to flip it over. So it would equal 4. These two together act like 4 ohms worth of resistance. And that's in series with the 6 ohm resistor. So you would just add those together. So all together, it's like you have 10 ohms of resistance. Another way to think about that, though, is you could have said R would be V divided by I, or 10 divided by 1. But sometimes you don't have that current given to you, and you might have to find this all on its own without knowing what those two values are. And the only way to do that, think about how these resistors add together. It's a little tricky there. And then to understand what voltage and current is, this voltage won't all be 10, and it won't add up to be 10. Because it changes. But let's say the current. All the current has to go through that 6 ohm resistor, so this has to be 1 amp. And how do I get that V? Well, V is I times R. So if I took 1 times 6, that means 6 volts across this resistor. Now these two right here, they won't be 6 volts, they won't be 4 volts, it's a little, I lied. It won't be 6 volts or 10 volts. But how it works out is that these 10 volts right here from the power supply, where are you going to lose it? Through 2 resistors. It goes through the 6 and loses 6 volts. And then it has another 4 to lose going through that next one. 4. How I'm getting that 4 is that the beginning voltage of 10 has to equal the first one of 6 plus whatever resistor goes through next. And it only gets to go through one of those. So that's why it's going to be 4. And the current? Well, that's V divided by R, or 8 divided by 2, so 0.5 and 0.5. The current got split up equally because these were equal resistors, and they each get half the current. For power, I times V, this would be 10, this would be 6, this would be 2, and 2. Okay, hopefully this helps looking through this. Your homework today is just to do those next 5. Just try the next 5, which is on the next page, practice 6. Which is just numbers 1 through 5. There's no combination circuits there, but just to get really comfortable with, the series and parallel on their own. And we'll look at those answers tomorrow. Hopefully these are making more sense. I hope you're watching these videos. I hope you're doing well. Again, Zoom, if you have questions, or email me. Until next time, take care.